Good morning.
Good morning, sir.
We'll wait a minute and let people come in. Let's see. Okay, semester's almost over. I'm going to push back, by the way, I'm going to push back the date for P3 for a few days. It is unconscionable that P2 is not graded yet for everybody, and the graders and I are working to fix that. So I think it's only fair to give people feedback on P2, even though there's only a tangential relationship between the two deliverables. So I'll put that in an announcement today. The good news is you don't have to panic tonight, and the bad news is it's hanging over your head still, right? If you feel comfortable turning it in, turn it in. By the way, we are getting towards the end of the semester here, so here we are. Next week is the last formal lecture. After that, I will give some information about data structures and algorithms. But those are not required. There's no testable material. It's the material that will help you as you complete your projects to give you some ideas of how you can store things in data form. And the labs are starting to wind down. Next week is the last lab. So the idea is for all of April, you are turned loose on your projects and free to do project stuff. And what we'll do in these sessions is have Q&A, help sessions, come here and ask questions. And then when the P4s do 5 and 6, I need to see those. I need to have a demonstration. So we'll use these time slots for that also. I'm also going to enlist the help of the graders, because with 93 of you, I can't do 93 demonstrations. They take about 10 minutes each. They're usually quite helpful because I get to give you feedback on your design, software technique, just give you hopefully good advice, hopefully positive advice. Joshua, you have a question?
Yes. When did you say our last lecture was? I didn't quite catch that part.
It's going to be next week is the last one. So next Friday.
Okay. Thank you, sir.
Yeah. Okay, the other ones will be, and I haven't created these yet, so let's see how I do. It is a minimum PowerPoint notes, and hopefully PowerPoint notes coupled with some pre-recorded lectures, but we don't need any live lectures. All right, so I wanted to talk more about a little bit more about design, requirement specifications. It's hard to look at this stuff too much and do that for about half the lecture and then go into my process for how I would produce the software for a project. And then hopefully have some time left for just general Q&A, if you have some specific things that you want to talk about. So I have some samples here of some people's, this is a software design document. The format's a little bit different than what we have in this class. But this product is as you can see, it's supposed to be a way to view asteroids, and they also want to provide some information about specific asteroids. So the idea is there are real live asteroid tracking sites where you can pull data from that have APIs, they have software interfaces. They want to pull the data from that and then show where the asteroids are on the, on the GUI, which is basically a map of the inner part of the solar system: Mars, Earth, Venus, Mercury, and the Sun. And then allow the user to do animations so they can watch the interactions, and also allow the user to get data about the asteroid size, composition, orbit, things like that. So that's the goal. So let's see. I'll give you a few minutes to read through this product description, and then I'll show you my comments here. Do I need to make that bigger? It wouldn't hurt, would it? Yeah, let's do that. All right, take a minute and read through that. I'm sure the people that are watching the recorded lecture are enjoying our silence. Hopefully they're reading too. All right, so here's my first question. If you were thinking that you wanted to use this product, what questions might you have about the abilities that you would have as a user that were not identified in this product description?
So I think at the very end, he says it's a 2D moving orbital simulation.
Yeah.
But he says it only includes the sun and the earth. I was just curious if maybe if he's going to be simulating maybe like the gravitational effects from other planets on the asteroid and see how they've I don't, I don't know if
Right.
he's simulating that as well. I don't know.
Right. So he or she left that up in the air, right? That we don't understand the scale of the model that they're going to create. So that's a good question. I would also argue that if you're going to use, if you are going to do a gravitational model, if you are, then you should include those equations in here, because that's part of the problem description that's going to describe the functional behavior of the software. Do we have other questions? First as a user, we'll move on to other stuff. Okay, how about writing quality? Are there any issues with writing quality?
I may be wrong, but I personally thought it was quite good.
Okay.
Yeah.
Okay, how about technical aspects? Are there any technical aspects that you would have questions about?
Maybe a little more of a description on how it works.
Okay.
Kind of.
Be careful about how, right? You have to do, you don't want to describe how the software is going to solve the problem, but you do want to solve how the problem exists in the real world, right?
Yeah.
From that aspect, you need to describe how it works. And that's why I'm saying you really want to include the gravitational models. And maybe some diagrams would be good. You mentioned before that you were wondering about like gravitational effects of the Earth. The moon's not included. And when things get close to the Earth, the moon is a significant gravitational body. So I would question that. And I would question, they say they're going to get their data from an API, but they never say where. You know, they never say what data set are they getting this from that has an API. In terms of writing quality, this live or relatively live, I don't know what that means, right? These are the fuzzy words that we try to keep out of our technical writing. The orbit of Venus. Okay, oh, I'm sorry. I thought I said Venus more or less, which would be no good, right? So they're saying outside of Mars and inside of Venus, they're not going to talk to. That's fine. Here's my comments. No citation for the first sentence. No citation for all the other facts in all these other sentences. They said creating fake data. By the way, I wouldn't use fake in a technical report. You can say dummy data. You know, there are other terms. Fake is a little too colloquial. But I'm pointing out that, you know, they can use this fake data as part of their development. That's not a problem. If you need to develop test cases, or let's say you're developing part of your software that's doing the visualization, but you haven't done the data capture yet. How are you going to test your visualization? Well, that's when you would use pretend data. Yeah, I think false data, random data, you know, fake is just a little too hokey, I think. Asking them to name the data source. They have requirements later on about listing proximity danger, but they don't put that in the requirements. And then I have here, is there a standard model, right? They have a proximity danger potential to Earth. How are they going to assess that? So I don't know if there's a standard model for that. And then they say other useful information. Well, again, that's those fuzzy words. You can't say that. You've got to say what you're putting in there. I'm assuming that what they're talking about here is asteroids that would be maybe sometimes within this band that they're talking about. Between Mars and Venus is the band, and maybe some asteroids, for all I know, I don't know, have elliptical enough orbits where sometimes they're in the band and sometimes they're not. Well, maybe that would be good to point out, that they're going to be shown as long as they're within the band. Or if they only want to show things whose orbits are entirely within the band, they should mention that. And then I'm asking them what data set they're using. And then down here, the 2D simulation. You know, if you watched a real-time simulation of the solar system, that's a pretty bad simulation because it's going to look static. All right, if you're doing real time, let's see, how far does the Earth move in 24 hours? You know, 1/360th of a circle around the sun. So I don't think most people would want to watch for 24 hours to watch that. So they need to keep that into account. I would think they want a faster than real-time model. And if they're going to do a faster than real-time model, they have to, again, I would think the best way to do it would be to use the equations of motion and say, here's the static situation at time 0, and then they can use the the static equations of I'm sorry, the equations of motion in order to do a faster than real-time simulation. Let's see, let's go back to the original. Here's some requirements. Now, these are not the kind of requirements you all have to do. These are the requirements for, they're higher level. They're not the testable requirement specifications that I'm asking you to do. So I don't want to spend too much time on them, but you'll see they have some of the same ideas. The product shall obtain live data from the APIs. We still don't know where that data is coming from. They do eventually mention that. The product shall display asteroids near Earth. I had a problem with this. Can you tell me what my problem with this one was? Product shall display asteroids near Earth, near meaning less than 500,000 kilometers.
I feel like he or she could have just said, without saying near Earth, just say the 500,000.
Yeah, you could have done it that way. The product shall display asteroids less than 500,000 kilometers from Earth. Right. If you're going to say near Earth and then you put a definition, and this is true of any requirement, if you put a definition in your requirement, you're doing it wrong. That definition should be up in the product description, right? They could have said, we define near Earth as less than 500,000 kilometers up in the product description. And then they could just say, use the term near Earth here, and it's well defined. Or like you said, they could already say less than 500,000 kilometers. I had a problem with this one. This is how they're going to do the future, right? Extrapolate the historical data of the plotted asteroids. Can you guess what my problem with that one was? You guys learned extrapolation. I'm thinking, if I remember right, we had to learn it in algebra, or maybe in trig class. We did interpolation and extrapolation, but that's because we had trig tables instead of calculators. So what are you doing when you extrapolate something? I know you know how to do it. You got to define it, right? Here's what, normally what extrapolation looks like this. You take a bunch of data, you do a best fit curve, and then you extend that curve beyond the data, right? It's a statistical technique where you're taking the existing data and saying, if these trends hold true, here's what future data should look like. And I don't know if that's what they really want to do. I think I think they should use, if they want to show the future movement of these things, they should be showing the gravitational motion equations, which quite frankly would be much easier than extrapolation. Because with extrapolation, they're going to have to come up with some interesting ellipse curves, best fit curves to the data. And so there's two separate techniques there. And so I asked them to clarify what technique. Did they really mean extrapolate, which is a specific mathematical term, or did they mean extend via some kind of a model of motion? I had an issue with this one because I think it's a duplicate of number one. Number one says you have to obtain live data, and number 8 says you have to get new live data. I think if I can get live data, I should be able to get new live data. So I'm not convinced that that should be a new requirement. These are, by the way, high-level requirements. They're not required to be testable. I don't know if I had any comments to these. I'm sure I did. Let's look at these for just a second. I'll give you just a few seconds to look over these user stories. Is the format correct for a user story? Yeah, they did. I would like to instead of I want to be able to. Yeah, I'll accept it. But you're right. You're right. I would like to be able to instead of I want to be able to. But they follow the general format. As a blank, I want to blank. So I'm okay with that part. I don't think, yeah, go ahead.
So, is there like, was there supposed to be like a chart in the in like the paper for the user stories?
In your document or in this document?
In our document.
I don't ask for a table. I do recommend that you present them as some kind of a bulletized list or a table with an identifier by each.
Okay.
Line after line. Don't put them in a paragraph. That's awfully hard to read. But I don't think I had a hard format requirement. I think here, like as a user, I want to see data. I think that could be turned into multiple user stories because there's a lot of different data. And I think here where they say they want to turn this into a model, into a predictive simulation, I think again, this goes back to, are they doing extrapolation or are they doing a real physics model? I think that's fine. They did mention it. They didn't put that in the requirements, by the way. It should be in the requirements. And problem solution, here's their UML. Let's take a look at that. I'm just going to give you a minute on that one. I didn't make any comments to their UML. What do you think?
I think the mass is stated twice in the sun and earth, but there's some extension for the attributes.
Yeah, and what they're choosing to do is restate all the attributes, which we had that discussion in this class, right? When I extend something, I'm not going to. I personally wouldn't relist the attributes because it's understood they get inherited from the parent. But they're choosing to relist them. That's okay. Now, the bad news is if they actually do create new X position, Y position, let's say in Earth, they've really screwed up because they've done a bad thing. It's called shadowing, and you're hiding the attributes from the parent, which is going to cause you weird problems. That's a good point.
I mean, maybe like there's not many methods. I don't know. Never mind.
Yeah, there's not many methods. Yeah, so I think they just didn't list their methods yet. They haven't thought through that far yet, right? I don't think we have a method called method type. I think that's their placeholder, and that's kind of okay. They're doing a process where they don't have I'm not requiring them to have as complete a design sketched out as I am with you guys. My biggest issue with this is that the Earth extends the sun and the asteroid extends the Earth, and I don't think that's necessary. I think if they made the generic class with all of those attributes that the asteroid has, that they could then model the sun, the Earth, and the asteroid just by setting the proper attribute values. For example, AU, the astronomical unit, that's the distance, right? What is it? One AU is the distance between the Earth and the sun. Is that right? Do I remember my?
Yeah, that's right.
Okay. So everybody could have an AU, and for Earth it would be 1.0. For the sun it would be 0.0. And then for the asteroid, it's whatever the asteroid is. So I think all of those could be done with attribute values. I don't think these things behave differently. The sun doesn't move, but that's okay. You give it a speed of 0.0. And then the Earth moves around the sun, and the asteroids move around the Earth, and move around the sun also. And all of that can be taken care of with equations of motion. It doesn't necessarily need to be a separate class. I don't see any real behavioral differences between the sun and the Earth and the asteroid. They're all following gravitational model. Now, here's where you have some differences. If you're going to track motion and you need to have like a big array of locations so that you can do that thing where they plot out on the map, then maybe we can argue that the asteroid and the Earth have a usage for that and the sun doesn't. On the other hand, you could have a big plot of the sun's motion where it's just in the same place all the time. Technically, it's not, right? But in this case, we would use the sun as the center of the model. So I didn't worry too much about that, but those are things that we could delve into. Let me do the same thing. They've got a requirements. They're doing a requirements document, and I wanted you guys to look at these specifications. Here's the kind of specifications, the requirements that I'm asking you guys to do. So you can look and see what you think about these things. Remember the questions to ask. Are they atomic? Are they specific enough to be measurable? Can they be tested? Can you cheat them?
So the use of the word necessary.
Yep.
Oh,
Yep.
the necessary error message.
Yep. I've already met that requirement because in my opinion, it is never necessary. If you do need to have an error message, then you need to specify exactly what the error message is. And if there's 5 different errors and 5 different error messages, you've got 5 different requirements based on the mechanism that failed. And all of those error messages can be defined up front. You know, what I didn't show you is this is all prefaced with all that background material like you're supposed to have in your document. And so we would have all of that can be defined up in the background material. Similarly, I look at R.02, the product shall implement data for asteroids in helio orbit. I don't know if helio orbit was defined. I'm assuming it's around, orbiting around the sun. But I don't know what the data is. Implement data. I don't know what that is.
Also, simple simulation. Well, what does simple mean?
Exactly. We don't know what that simulation is. But the simplest simulation is a blank screen. So I've already met that requirement. These things, go ahead.
Another nitpick I could see is the requirement 13 saying via mouse click, but it doesn't say which mouse button.
Right. And my thing with this is I've got 2 of these. One is this is you have to have a user interface. That's really not a specific testable requirement. So that should go up in their broader requirements, right? The one that I said that we were looking at earlier that was not not in the format that I'm asking you guys to do, because that's not really testable, right? Maybe it's a user interface with a Space Invaders game. Well, we've met the requirement, right? So that's really a higher level requirement. I would take that out of there. And then here, the issue here is they're not specifying which mouse clip, but I would go the other direction. The program shall allow the user to interact with the displayed objects, period. And via mouse, remember what you do in the requirement is you have to specify what you want to happen, but not how it's done. And so once they add the words via mouse click, they're adding how it's done. Now it may be that that's actually a requirement. It may be that that's the correct, that's absolutely what they need in there as a requirement. But I would say as a general rule, you want to have, you want to specify what the behavior is, not necessarily how it happens. And also that you allow the user to interact with the displayed objects. Well, what's the interaction? Again, doing nothing is an interaction. So I've already met that requirement.
I do have a question about that though, after what you just said. So in my program, after you said I could do like the missile command spinoff.
Right.
So I'm controlling like the missile silos, like with the 1, 2, and 3 keys. Is it okay to
Right.
specify that like each one is controlled by like a different button for the requirements?
Yeah, and you can just say you have a mechanism and each one is a unique mechanism. And what you're going to have is, I'm assuming 1, 2, and 3 do 3 different things.
They do the exact same thing, but they're just controlled by different buttons.
Okay, but they're for, what's the distinction? Why do you have 3 buttons?
One's on, so one of the silos is on the left, one is in the middle, one is on the right.
Got it.
Yeah.
Okay. So then your requirement can be, you might want to have 3, left silo, there's a mechanism to control left silo with the.
Yeah, that's what I did.
You could do it that way. And you don't have to specify what the mechanism is. It can be, mouse clicks, key clicks, yelling at the machine, whatever.
All right, thank you.
Mm-hmm. They cut and pasted this, so of course they have the same issue as before. And we still don't know where the data is coming from, right? We don't know what data. We were going to obtain live data, but we don't know what that data is. And then it's through an API, but we don't know the API to what. Twitter has an API and Facebook has APIs. So that needs to be defined. Now that can be defined in the text above. It doesn't have to be in the requirement. It can be defined in the text above. I suspect one way to do this would be if you're going to get data through via an API, usually the way that works, and you have to, they would have to read up on how this specific API works. Usually the way that works is data will come to you like in a big string, and that string has a bunch of fields, and each field has a specific purpose. And you need to parse out that string. So that's really the kind of requirement that they want to get to. Number 1, they can receive the string. Number 2, they can parse the string. And so that's the level of detail that they want here. I can't remember what my comments were. Yeah, I had a bunch of comments. Right? No definitions, have the data. Product shall have the data. I don't know if that's testable. How do I know if it has the data? When you're thinking of these requirements, think in terms of testing and think in terms of not user actions. So you see a lot of this is the user, in display. That's really not testable. You know what's testable? An attribute value. So instead of saying the program shall display asteroid data, well, how are they going to display asteroid data? They're going to have a pane built up in a particular form with some content in it. And that pane has a name. And then when they want to display that data, there's going to be a method that gets executed that let's pretend they do the border pane trick that we talked about the other day, that would say set pane, display pane, data display pane. And then you can actually look at the value and ask the border pane, what is your current pane in the center? And it will say data display pane. So you can actually query that and get that as a value. So rather than relying on your eyeballs, which are not calibrated, you can look at attribute values. And that's where you want to think in terms of testing. Not I pushed a button or I clicked a mouse. It's this method executed and it had a job to do, and it should have a very specific result. And I can see that result because maybe an attribute value changed from 7 to 17. Now I can go look at the attribute value and see if it really is 17. And your input conditions are, I'm going to set the attribute value to 7, run the method, and then I'm going to look at the attribute and see if it's 17. You can do that with print statements. Again, you can write your own code purely for test purposes, where you inject all the values that you need into the attributes to set up the simulation or to set up the test case. And then you call for a method to be executed. And then you look at the attributes that you need to tell you if you had a successful test or not. And you can do all that with printouts. Now there are tools for that. There's JUnit testing, and within Eclipse, JUnit testing is probably the most popular. That's beyond the scope of the course. If you want to do it, by all means, it's another learning curve, right? It's another tool. You're welcome to do it. But even without that, you can write your own methods that are there just to test. And the advantage is, once you write that method once, you can instantaneously retest. Okay. I hope this was, whoops, I didn't want to do that, but that's all right. I hope this is helpful. Looking at other people's work and critiquing it and seeing what they did well and what they did unwell. For example, the format of laying out those things in tabular form, that's good stuff. Tables are great. And there were some other things in there that are not required for this class, where they had to list all their acronyms and they had to provide a bunch of definitions ahead of time. That's all really good stuff. Okay, now you're getting close to where I turn you loose to actually start programming your project. The goal at this point is for you to have done enough thinking about the project ahead of time where the actual creation of the software is a relatively boring exercise, right? The actual writing of the code is often the least skillful part of developing software. The skillful part is developing the understanding of what you want the software to do, and then producing a good design. And this goes in the kind of flow that we've talked about in the course. Understanding what you want the software to do, that's discussions with your customer. And then specifying what you want your software to do, that's your requirements. And a large number of software, I think the number is something like 40% of software errors, something like that, are actually requirements errors, not coding errors. So that's the difficult part. That's the tough part. You guys are through the tough part, right? You've done your product, your problem description, you described the thing you want the software to do. Now with P3, you've done your design where you think you have an idea of the design that will implement that problem solution, you're through the hard part. You're in the easy part now, which is actually now writing code. And if you've done the first two parts and really put effort into that, then the easy part really is the easy part. If you have not put that much effort into it, or if you're, even if you put a lot of effort into it, but you were, kind of confused because it's your first time through the process, then the coding is going to be hard. And the reason the coding is hard is not because the coding itself is that hard. It's because you are still so unclear about your design that you have to keep going back and redesigning. Now, I don't want to make it sound like people who are having a hard time coding in April was because you were lazy in March. That's not a good message to send out at all. You guys are still learning the process here, right? This is your first or second or third time through a design effort. So you're not supposed to be excellent at it yet. But the idea is to give you this idea of an understanding of the process and an understanding and experience in putting designs together. So I showed you the Pirates game, the beginning of the Pirates game. I showed you that as an example last week as part of the timeline animation example. And for that, I showed you this UML diagram. And were I to actually build this from scratch and do it properly, again, the reason it's garbage software, and the reason it's garbage software is because I didn't follow the process, right? I just started doing what everybody else does and coding on the fly. And so, and of course I made decisions that I regret because I did it that way. But if I were to do it from scratch, I would lay out this UML diagram. I'd spend a little time on it, clean it up, make sure I believe in it. And then I would start coding. And the way I would do the programming, the way I would do the coding, is I would take every one of these classes and make a class file, a .java file for every one of them, put all the attributes, put all the methods in, and all the methods return dummy values. So the methods that have a void return type basically just print out method so-and-so in class so-and-so has been called, has not been defined yet. And if you have to return a value, if the return type of the method is a double or an int or a string, I would basically return dummy data, 0, -1, a string that says this is a dummy string. And again, I would print out method so-and-so in class so-and-so was called, has not been defined yet. Now, why would I do that? Again, this is my process. It doesn't have to be your process, but the reason that well, I guess it does, because I'm asking you in P4 to have all your classes laid out with all the methods, even if they're empty. So I guess I am enforcing this process on you. You should give me feedback if you like it or not. Why am I doing that? Because eventually I'm actually going to want to code the real stuff, and I want to test it. And I don't want to test it by just running the code and saying, looks good. Right? I want to test it with real test cases. So then I can say, okay, and now again, you guys only have to do 15 real test cases. The rest of it's going to be, looks good kind of stuff. But I would do a real test case where I say, okay, now I'm going to create a situation where, my ship is at speed 11 and my ship is at position 1010, and I'm going to call the move method one time, and I'm going to verify that the ship is at position 1111. Right? Specific input, specific output, observable, measurable, and the human user was not involved at all. I can run that test without a human user. And then I might want to test that, I've got a circle on the screen that represents the ship. I might do a test to verify that the circle actually follows the ship appropriately. So after one tick of the animation, the ship was at 1010, the circle was at 1010, the ship moved to 1111, and the circle should be at 1111. I'm not going to watch that with my eyeballs. That circle has an X location, Y location attribute. I can actually have that be printed out. I can actually measure that. So that's why I would first lay all this out so that I have access to all of my classes. They all work, even though they're not doing anything correctly. And any kind of test I want to create, I can do. If I want to make sure that when I click a button on the GUI and the GUI and the Pirates play pane, the Pirates play pane has a method, move all ships, right? I click the button, move all ships is executed, all the ships get moved. I can't do that unless I've got at least the play pane, the Pirates game manager, and the player ship already instantiated. So how would I do that? I wouldn't do it by actually pressing the button as a user. I would just make a method that executes the move all ships method. And I would make a test case, a test method inside my code that just does move all ships without me having to push the button. Because what's the button press do? All it does is make move all ships method fire. So why put myself as a human? Why have the clunky way of doing the testing when I can do automated testing? If I build that method, then it can run. If I'm doing it with the button press, I don't know where the ship began. I don't know where the circle began, so I can't do my pre-test, post-test to comparison to make sure I got it all right. Does that make any sense? Are there any, do you see any problems or, oh my God, how am I going to do this kind of situations? Okay. That's either fear or acceptance. I can't tell. All right. So
probably a mix of both.
yeah, maybe a mix of both. Yeah. You have to go through the process a couple times. And that's why, you know, again, as individual projects, most of you have a reasonably sized project. Well, this is not intimidating. And again, I'm deliberately descoping. So you only have to do 15 test cases. And by the way, you're probably going to do 3 of them on this method, or maybe even 6 of them on this method. Well, that makes life easier because basically all you're doing is you have one test method and you're putting in different value. You're seeding it with different values and then running it, right? So that makes things easier. You only having to do 15. At the worst case, you're going to create 15 test methods in your code. Again, if you follow my advice. So at the worst case. Now you can imagine if you're really doing a full test of your code, you know, you may have scores or hundreds of test cases. We're just doing 15 here. And then the question is, well, oh my gosh, how do people ever do that? Well, first of all, it's your 8-hour-a-day job, not your 1 out of 4 or 5 classes job, right? So you have a lot more time to work on it. And secondly, using the testing tools does improve your productivity once you learn how, you know, once you get comfortable with using them. And again, in this class, I'm not requiring it, and there will be a learning curve for you to try to use them. So if you want to, you know, you have to expect that you're going to be expending more effort up front for the payoff later on down the road. But I would lay out all my code this way, you know, with all the methods as dummy methods. And for your P4 deliverable, that's the requirement. So I'm imposing that on you. And then how you choose to flesh out the code after that is up to you, right? That's what the user stories are for. The user stories took the big problem, carved it up into smaller problems, and then prioritized them. So you could say, okay, the first thing I want to get going on my code is this user story. So there is method to this madness, right? We are taking the large problem, carving it up into smaller pieces that are informal description of functionality using the user stories. And then from there, turning for each user story, I'm only asking for how many requirements? 5 requirements. I'm only asking for 5 requirements, but in theory, for each user story, you would come up with a specific set of requirement specifications where you would say, I cannot claim this user story is done till all these requirements are met. For each requirement specification, you make test cases, and you've already laid out your UML, and now you can begin to code. So you see why the coding is the most boring part, right? You've done all your hard work, all your design work, all your thought work up front. Now, there is I gotta let you go. There is a mechanism, we are following this agile process, so it's actually a little more mixed than what I'm talking about. Often you won't build your requirements for a user story until you tackle that user story. That wouldn't make sense for this class, unfortunately. So I asked you to do some, that sample of 5 requirements up front. But often you may say, okay, we know we have to do these things. We've got a rough idea of our architecture here. We know how the classes relate to each other. Now we're going to do the user stories. Before I do the coding for the user story, now I create the requirements and test case for that user story. So you don't have to do it all at once, and you don't have to get it all right at once. Okay, other questions? We're over time. I'm going to let you go. Have a great weekend. Look for my announcement about delaying the due date for P3.
Have a good day, sir.
Thanks, you too.
Thank
Have a
you.
good one.